All right, so let's do an example. So consider the matrix, the 3 by 3 matrix A, which is 1, 2, 3, 3, 2, 1, -1, -2, -3. Let's see if we can follow these steps and calculate its determinant. All right, so let me pick a color here. Black's fine. All right, so first we choose a base column. Now, looking at the matrix, there's no zeros, and, well, I don't like negatives, so let's just pick the first column, right? Because that's normally what everyone else does, unless there's any zeros. So let's pick the first column, right? So the second step says to take the first number in the column and isolate the corresponding cofactor matrix, right? So we talked about this in the previous video, right? So the number 1, right, the first number in the first column, number 1, is contained in both the first column and the first row, right? So if we isolate the first column and the first row, you'll see that the corresponding cofactor matrix for 1 is 2, 1, -2, -3, right? So we would have, so then, since that's the, right, so that's the corresponding cofactor matrix, right? 2, 1, -2, -3, right? So this determinant would ultimately be 2 times -3, -6, minus a -2, right? So this would be -4, right? So that's the determinant of the cofactor matrix, right? So then we multiply that number, meaning that the number in the first column, right, with the determinant of the corresponding cofactor matrix, which we just calculated, -4, right? So let's find my eraser here and rewrite that. So it's -4. So we have 1, right? So we have 1. Let's write that here. So we have 1 times -4, right? So let's do it for the second number in the first column, right? So that's 2. So then the corresponding cofactor matrix, right? Recognize that the number 2 is in this 2. I should say, right, because there's 2 of them, is in the first column and the second row, right? So if we isolate the first column and the second row, we see that the cofactor matrix for the number 2 is 3, 1, -1, -3, right? So that's 3, 1, -1, -3, right? And so this determinant is going to be equal to -9 plus 1, which is -8, right? So we take that number and multiply that, right? So we take that number being, in this case, now it's 2, right? And we multiply that by the determinant of the corresponding cofactor matrix, in this case, -8, right? So then we have 2 times -8, right? Again, get our eraser, get rid of this. Just to do it for one more number, right? Last number in the first column, which is number 3. Again, realize that 3 is in the first column and the third row in this case, right? So if we isolate the first column and the third row, we see that the corresponding cofactor matrix for 3 is going to be 3 to -1, -2, right? And so the determinant of this matrix is we have a -6 and we have a minus a -2, right? -6 minus a -2 -4. Okay? And so we take that number, right? That number being 3, in this case, we multiply by the determinant of the corresponding cofactor matrix, in this case, -4, right? So then we have 3 times -4, right? So now what? This is the confusing part. Now we have to add these together. Now, considering the fact that we use the first column in this case, right? So the first number is going to be positive, right? Based on this little matrix here. The first number is going to be, I guess I should write this in purple. The first number is going to be, so then the determinant of A, right, is going to be these numbers added up. But we have to be careful of the sign. So the first number, since it's in the number 1 we're talking about, right? So it's in the first column, first row, so it's positive. The second number is going to be negative, and the third number is going to be positive. Okay? So what we do is to calculate the determinant of A, we just add these numbers up, right? So let's do that. So then we have, here we have a negative 4, and we have a positive 16, and we have a negative 12, right? So then here we have a negative 4, negative 12, negative 16 plus 16. Well, guess what? That determinant is actually 0. And it's funny because I just came up with that off the top of my head. And that's actually kind of funny how that worked out. But yeah, negative 4, negative 12, 16, 16. Yep, that's 0. So anyway, so that's how you do it. Again, you rinse and repeat this process for any 3x3 matrix that you have. And just, be mindful of zeros, and just do a lot of practice. And I know it seems really arbitrary and really weird, but this definitely does have some applications in various different sciences. So hopefully this helped. And remember, just keep doing those examples, and you'll eventually get the hang of it to the point where it's just so second nature that you don't even think about it. And we will see you all in the next video.